In this video I'm going to talk about solving rational equations, which means equation that contains rational expressions. So let's see the first example. So we have 6 over x minus 1 equal to 3 over x minus 4. Since the equation contains fraction, what we don't like? We don't like denominators to be 0. So the first step is to find the values of x which makes the denominators zero. Okay? Denominators must be different from 0. This is the first step. For what values of x the denominators are different from 0. And then exclude those values as solution. They are not solution. So they will not be on the solution set. Okay, now let's see. What we don't like? We don't like the denominator to be 0. So x minus 1, we want different from 0. X minus 1 is equal to 0 if x is 1. And x minus 4, we need it different from 0. X minus 4 equals to 0 when x is 4. Therefore, 1, 4 are not solutions. What do we want? We want x different from 1 from 4. Now let me write the equation again. Okay, since x is not 1 and 4 for us, so we can go and now work to solve this equation, and this is just a proportion, and we know how to solve a proportion if the equation contains one fraction on the left and another fraction on the right, so we cross multiply, which means the numerator on the left will go and multiply the denominator on the right. And the numerator on the right will go and multiply the denominator on the left. So, since x minus 1 and x minus 4 for values of x different than 1 and 4, we are not multiplying by 0. So 6 will go and multiply x minus 4, and 3 will go and multiply x minus 1. So I have 6x here, minus 24, equal to 3x minus 3. Since the equation contains x's at both sides, I have to remove x's from the right if I want x on the left. If I want x to be on the right, I have to remove x that is on the left. In this case, I like to have x on the right, so I have to eliminate x from the left. And doing this, I have to subtract 3x at both sides of the equation. So positive 3 and negative 3, this is 0, 0 times x is 0, x disappeared. And in the same time, I don't like the constant to be on the left, so I have to destroy the constant from the left side. I have negative 24, I must add 24 to get 0, both sides of the equation. So, what I have, I am left with x's on the left and the numbers on the right. Okay, so I have 3x equal to 21. The last step is dividing by 3 both sides, so x is 7. Okay, now x is 7, and 7 is different from 1, 4, which are the values of x that are not allowed to be. Therefore, 7 is a solution. Let's go and work on another example. Example 2. I have x over x minus 3 minus 2 equal to 3 over x minus 3. Okay, so still I have fractions. So what is the denominator of 2? The denominator of 2 is just 1. So the first thing, I want x minus 3 to be different from 0. So x will be different from 3. So x equal 3 is not a solution. Now, so here I have to work a little bit different. This is not a proportion because I have one fraction on the right, but I have two fractions on the left. So I can make this one fraction, but why? It will give me a little bit more work. So what I'm going to do, when I look at the denominators, I see that the LCD is x minus 3. And if I multiply by LCD each term of the equation, so through the equation, so the denominator will be not anymore. So this is my plan. I have to multiply through the equation by LCD. Why? In order to eliminate the denominators. So LCD is exactly x minus 3, so no more denominators. So this was the plan. Let me go now and work. So what I have x over x minus 3 minus 2 equal to 3 x minus 3. What I know that LCD is x minus 3, and x cannot be 3. If x is not 3, so the denominators are not 0. Now the second step, I'm going to multiply by LCD. Minus 2 times the LCD equal 3x minus 3 times LCD. And as I planned, no more denominators. So what I have x minus, let me rewrite this now, I am not multiplying right now. Now let's pay attention in this row, because I want to go from the first row to go here, okay? Now, what we see? We see that the first fraction, okay, is just x. Why? Because LCD is the denominator itself, so that means that I'm not missing nothing in the first fraction, okay? So I have to write just the numerator. Now, when I see here, the denominator of 2 is 1, so what is missing? Here is missing LCD, x minus 3. So I'm going and multiply this term by the LCD. Let me show. This needs only multiplication in this case. And when I go to the other fraction, what I see? I see that I am not missing nothing from LCD. So 3 will be still 3. So working like this, let me go again, because this will continue to work for other problems. So again, I have x over x minus 3 minus 2 equal 3 over x minus 3. I know that here we have a denominator 1. These denominators are exactly the same. This denominator cannot be 0, so x cannot be 3. And also LCD is just x minus 3. Now, in order to eliminate the denominators, I will multiply by LCD each through the equation, so each term. So we will go and multiply each term by what their denominators are missing from the LCD. This is exactly that we did in previous work. So here I am not missing nothing, so no multiplication here. Here the denominator is 1, I am missing LCD. So this will be multiplied with x minus 3. And the fraction here, it doesn't missing anything because this is LCD itself, so no multiplication. So this gives me a lot of time to save, and what I have, so I have x minus 2 times x minus 3 equal 3. And if I go, this will give me x minus 2x plus 6 equal to 3. And now I will combine here x's. So I have x on the left, and I will remove this number to go to the other side. Okay, now I have negative 1x equal to negative 3. And to make this negative x a positive x, I just multiply through the equation by negative 1, which means just change the sign. So it is negative, change the sign, make it positive, and also change the sign of the other side. So x is equal to 3, but oops, x is not allowed to be 3. X must be different from 3. Therefore, 3 is not a solution. No solution for this equation. Why? Because x is not a real number. That's it. So no solution. Why? Because the only value for x that we got from the work was 3, but we know that x cannot be 3 because our denominators become 0. Example 3. I have 2x over x minus 7 minus x over x minus 4 equal to 12 over x squared minus 11x plus 28. Now, the equation contains fractions. What we said, we want to multiply by LCD each term at both sides of the equation in order to eliminate the denominators. Okay? Now, for this I want to know what is LCD. And I see that I have here x minus 7, x minus 4, and I have a trinomial here. So if I factor the trinomial will be two binomials, okay? So you can multiply those two and check if the product is this trinomial. But not always. You have a trinomial that will be exactly as in a factor form like this, okay? So what is the first job that you have to do? So first factor the denominator, okay? So is this factorable? Of course it is. Positive product means both signs are the same, both signs are negative, and I have 7 and 4. Because 7, 4, 28, and this is 11. So exactly we see that LCD is x minus 7, x minus 4. Okay, now I want to know for what values of x this is not a true statement. Now, let's see. Here, I have x equals 7. Because if 7 minus 7 is 0, here I have x equal to 4. Because 4 minus 4 is 0. So I'm looking now for zeros, okay? And the same thing. Therefore, x must be different from 4, 7. And LCD is just the trinomial. Now, let me rewrite this again. To x minus 7, minus x minus 4, equal to 12 over x squared minus 11x plus 28. So x cannot be 4 and 7, and this is LCD. Okay, and the denominators are factors of LCD. So, I'm going now to multiply the first numerator with what I am missing, with x minus 4. So I have 2x times x minus 4. I have minus x. So the denominator is x minus 4. I'm missing x minus 7. And here I'm not missing nothing, because the denominator here is itself LCD. So now let me go and multiply 2x squared minus 8x minus x squared plus 7x equal 12. So let me combine. What I have here, I have x squared, I have x, and I have a constant to the other side. So what this, when I read this, it gives me an idea that I have a trinomial here, okay? A trinomial, a quadratic polynomial. So let me take a note here. So remove 12 to the other side. To get 0 to the right. Okay, so I am removing negative 12 to the other side in order to get a 0. And let me combine now. I have what? I have 12, 2x squared minus x squared, which is 1x squared. I have negative 8x plus 7x, which is exactly negative 1x, and I have negative 12 equal to 0. Okay? This was my idea. Let me write again. You can work faster if you want. So combining like terms, removing 12. You don't need to rewrite, just show a row, and 12 will go as negative 12 here and will disappear from the right. So let me combine 2x minus x squared, negative 8x and positive 7x is negative x, and negative 12 to the other side. So, is this factorable? Of course, for this reason I moved the numbers. So during the work, your eyes are going through the equation, okay? And you see things before you write them. So this is negative 12. It is negative 4 times positive 3. And this will give me a negative 1. So xx negative, the highs will be negative, the other will be positive, 4 and 3. And now I have to leave each factor equal to 0. And this will give me x is equal to 4. And this will give me x is equal to negative 3. Okay, so what I did here, so I added 4 to both sides. And this 4 is gone. I subtracted 3, and this is gone. Now, are these the values that are not allowed to be solutions? No. Only 4. So 4 is excluded. Okay, so keep in mind, x cannot be 4, cannot be 7. So the only solution here is x equal to negative 3. Okay, but you don't need to write, just stop here. Example 4. I have 3 over x plus 7 minus 5 over x squared plus 2x minus 35 equal to 44 over x minus 5. Now, as we see, we have x plus 7, x minus 5 a trinomial. We see that negative 35 is 7 times 5. Okay, and 7 minus 5 is 2, so 7 will be positive and 5 will be negative. So this is exactly factored as x plus 7 times x minus 5. Okay, but let me show. So I have xx, negative product, different sign, the highest will be positive and the smallest will be negative. Okay, and also this is what? This is LCD. Now, since I have LCD here, I can find the values that x cannot take in order the denominator to be different from 0. So x will be different from negative 7 and different from 5. No discussion, because if x is 5 and negative 7, the denominators become 0. Okay, now we have LCD also here. And we are ready to go to eliminate the denominators from the equation. So the first fraction is 3 over x plus 7. So I have to multiply 3, but what I am missing from the LCD, and I multiply with x minus 5. Minus 5 Am I missing something here? No, this is LCD itself. Equal 44. I have to multiply, but what I'm missing, x plus 7. No more denominators, so let me continue. 3x minus 15 minus 5 equal to 44x plus 7 times 4, 28, so 308. Now I have to combine this, and this is negative 20. Let me rewrite again. And I have to decide where to keep x. So since x is greater, is larger than the left, I will keep x on the right. So if I want x on the right, that means I want numbers on the left. And this is telling me to destroy 3x. I have positive 3x. If I subtract 3x to both sides, so x disappears from the left. And also, I don't like this number close to my x. So I have to destroy this by subtracting 308, both sides. So, as I wanted, I have 41x on the right, and on the left I have a negative number. Be careful, if you have two negative numbers, it is addition, keep the common sign, and this is 328. So if I divide by 41 both sides, because I want 1x, so x is what? X is 8, but negative. Okay, if you have a negative sign in the division, the answer is negative 8. So the question is, now I'm asking, is this allowed, a value allowed to be? Yes. So x, let me write here. Since x is negative 8, different from negative 7 and 5, negative 8 is a solution. You don't need to write this, just accept this. And that's it. After you put a question mark, understand, if you check it, that you accepted this as a solution because it is a solution. Okay? It is not a value that is not allowed to be. Now, let's see another example. Example 5. Let me go to the next page. I have 3x over 2x minus 1 minus x over x minus 1 equal to 24 over 2x squared plus minus 3x plus 1. Now, this trinomial here, the coefficient of x squared is not 1, is 2. Okay, so for some reason students have some difficulties to factor a trinomial like this. If you don't like to factor, just check those two others, multiply those two, and if they give you the trinomial, then this is factorable as a product of two other binomials. This doesn't happen always, but you check. So what does it mean? 2x times x, 2x squared, 2x minus 1, negative 2x, and negative x is negative 3x. Negative 1 times negative 1 is positive 1, yes. This is factorable as a product of these two binomials. 2x minus 1 times x minus 1. Which means that this is LCD, and we are very happy. Okay, LCD is a product of two other denominators, so we can find the values directly from here or from here. So here, 2x minus 1 becomes 0 if x is equal to 1/2. Okay, and here x minus 1 is equal to 0 if x is 1. What this means? This means that x cannot be 1/2 and 1. And this is also LCD. Now I am ready to multiply fractions, but what they miss from LCD. So 3x will go and multiply with the other. And x will be multiplied by the other. And 24 with nothing. Or we can say number 1. Okay, it is missing nothing, so no multiplication, or you can say we'll multiply by 1. Doesn't matter. So let's go now and multiply. 3x times x is 3x squared minus 3x minus 2x squared plus x equal to 24. Still we have x squared, x's, so the idea is to send this 24 as a negative 24 to the other side in order to get a 0 to solve by factorization. So what I have to combine 3x squared and negative 2x squared, so this is 1x squared, and I have to combine negative 3x and positive 3x, so this is negative 2x, and I will send negative 24, okay, I have negative 24, 0. So may I factor this? Of course, yes. For this reason I moved 24, okay. So I have to factor the left side. A negative product means different sign, the largest will be negative. So this is 6 times 4. 6 times 4, 24, 6 minus 4, 2. And now, this will give me what? This will give me 6, and this will give me the opposite, negative 4. So, these are the values that solving the equation gave me. Now I have to put a question mark. Are these allowed? Yes. So they are different from 1/2, 1. Yes, accept it. Two solutions in this case, because they are not the values of x that makes our denominator 0. And the last example, example 6, 4x, 3x plus 4, minus x over x plus 2 is equal to 21 over 3x squared plus 10x plus 8. So, let me check if this trinomial is factorable, okay? And I would like to be factorable, and I would like that the factors will be the other denominators. This doesn't happen always, but I like it. Let's see. So, let me check. 3x squared, 3x times 2, 6x, 4 plus 4x, 10x, and 4 times 2, 8. Yes, it is. But be careful. You need to factor this now? No, because you checked. So we have to write 3x plus 4 and x plus 2. Now, if you don't like to check, let me recall you how we factor this, okay? So what we have? We have 3x squared plus 10x plus 8. So how we factor this? We factor 3x 3x. Even though 3x times 3x is not 3x squared, is 9x squared. Okay, now this recall us to simplify later. So the product now is positive 24. A positive product means same sign, both are positive. And 24 is 6 times 4 to give us 10. And now I can simplify here by 3. And the final answer is just x plus 2 and 3x plus 4 exactly as they are. Okay, but you can check here again. 3x times x squared is 3x squared. 3x times 2 is 6x plus 4x, 10x. 4 times 2, 8. So checking is, you can check if you know the process, okay? So what this means, this is LCD, a trinomial or in the factor form. And now, what are the values of x that are not allowed to be? So 3x plus 4 is 0. So this 4 will go to the other side by changing the sign. Dividing by 3 will give us negative 4 over 3. And this is 0 if x is negative 2. In other words, x cannot be negative 4 third, neither negative 4 third nor negative 2. Okay, now I am going to multiply each numerator by what is missing in their denominators by the LCD. So 4x will be multiplied with x plus 2, which is missing from LCD. X will go and multiply by 3x plus 4. And 21 will stay 21. And now I have 4x squared plus 8x minus 3x squared minus 4x equal to 21. X squared, x, the constant. Let me try if I can simplify. So this will be for x squared, this will be 4, and this will be negative, yes. Okay, now I decided to make this to the other side a negative number. Okay, so let me combine x squared together and x's together. So 4x squared minus 3x squared is x squared. 8x minus 4x is positive 4x. And I have negative 21 to have a 0 to the other side. In order to factor, as I checked before, is factorable. So a negative product means different sign. The largest will be positive. So this is what? 7 and 4. 7 and 3. Okay, so this, let me write this because this is the last example. So one factor is equal to 0, or the other factor is equal to 0, and this will give us what? This will give us negative 7, and this will give us positive 3. Why? So I subtracted 7 to both sides, and I added 3 to both sides. You know this stuff now. Now what is important to check? Are these values allowed to be solutions or not? Yes, they are. That's it. So this was the video for today, and the last video in the chapter about rational expressions. Thank you very much, and see you in the next video. when we are discussing about simplifying and working more on roots and radicals. Thank you again.